All right, hello everybody, and welcome to SQL Injection and You, the ultimate, final, and comprehensive workshop on the science, nay, the art of SQL injection. The subtitle here is how to personally crush and destroy the databases of your enemies, but I don't want y'all to get the wrong idea. We're all just learners. And while taking this workshop with me, I hope that you will join me in an oath of internet violence. Thou shalt not use this cursed knowledge to inflict digital wounds on the innocent or anyone who hasn't signed a rules of engagement outline. Yeah, that should do it. You are morally absolved. Now let's get hacking. Oh, by the way, the check-in code is in the corner there. It's crush SQL. Don't forget it because it's not on any other slides because I'm lazy. So if you want to get checked in on the membership portal, you should do that now. Moving on now. As always, thank you for stopping on by my workshop. It has been a long time since I have hosted a workshop, all the way back in, wait, when was it? Did I host any in fall? I don't think so. It's been a while. It's good to be back though. This workshop is being streamed to you from our custom live streaming platform called Oh, wait. No, never mind. No, sorry. I had like a weird memory there. Yeah, drink to that, everybody. Drink to that. All right, where were we? Oh yeah. This workshop and its contents are actually brought to you to your screens by ACM Cyber at UC San Diego. ACM Cyber is a special interest community of the largest technology organization at UC San Diego, a little known organization called the Association for Computing Machinery at UCSD, with over 300 members. This is ACM Cyber, actually, as of recently. We are one of the fastest growing organizations on campus, and that's saying something because we're in a pandemic. We aim to provide member, and I'll just skip all this crap. Okay, main thing I wanted to tell you is that we have the largest event of the year coming up in the spring. It's called San Diego CTF. It's a 48-hour Jeopardy style hacking game. Anyways, it's really awesome. We have like cash prizes for people who do well. It's like healthy for beginners. It's got advanced stuff in it. Stop by, please. It'll be really fun. But if you're new to this workshop, if you're new to ACM Cyber, stop by our Discord after the workshop. There will be a link for it, but if you're impatient, that's just acmurl.com/cyberdiscord to get a head start on that. Okay, this is me. You're probably wondering how I got here. My name is Aaron, and I've been a notorious web hacker for quite some time now. My day job is president of ACM Cyber. My greatest ambition is to one day graduate and perhaps even make some money at some point. My fun fact is that I am sleep deprived, have 2 midterms, and 3 homework assignments due this week. So with that out of the way, let's check out today's agenda. Here's the breakdown. We're going to kick things off with some background and intro to the topic, kind of ease you into it a little bit. We'll dive into a fun little challenge for the audience. We'll talk about some of the more advanced techniques and tools for automating your SQL conquest. And then we'll polish off our private evening with one another with some more funsies. But to start with, we're going to do the intro. I'm going to go ahead and take a break real fast to look at the chat. Drink some Coke, everybody, or whatever you're drinking. And thank you, Chris, for posting the cyber link. All right. Hopefully you're all hydrated. I read the chat. Very interesting, everybody. You really keep that chat interesting. Let's keep going. So one thing I wanted to clarify is that SQL injection might not be a concept that is well known to everybody who hopped into this Zoom room. So to start things off, I wanted to make some distinctions. This talk is about structured query language, or SQL for short. It is not about any other kind of SQL, like the sequel to Shrek, Shrek 2, Although maybe we can make some time for Shrek 2 after this workshop if you are available. But unfortunately, that is not the main topic of today's workshop. Furthermore, when we talk about injecting, it is worth mentioning that we are injecting malicious SQL commands into vulnerable web applications. We will not be injecting the COVID-19 vaccine. We tried to get approved to have that distributed to the viewers of our workshop today. But unfortunately, the logistical task of distributing it over Zoom proved to be a little bit too difficult. So no, we're only going to focus on the SQL side of things of the injection today. On that topic, let's go ahead and try out the polls feature. I need to make sure y'all are still awake. So let's just come up with a random topical question. I'm not going to force you to respond to this one since that would be a HIPAA violation, but I'm going to go ahead and open this poll up. And y'all can give some clicking fingers some exercise. Just make sure everything's working. Let's see here. Oh, the polls are not prepared, I don't think. I thought they were prepared. They aren't prepared. We're not going to do polls today. You can post in chat, A, B, or C. How's that? I usually come in this with the polls prepared. B, A, B movie. It's my favorite movie. Yeah, I'm also B. They haven't got me chipped. A, at least one person's been chipped. What's it like to be able to leap over tall buildings? Yeah, exactly. How are the superpowers? All right. Good. This did exactly what I wanted it to do, which is to say it told me that the poll feature was not working properly. So depending on which polls come up, we'll either skip over them or answer them in chat just like you did. So make sure you keep paying attention, stay awake. Let's go, drink your Coke. All right, let's do this. So the prerequisites for this workshop are fairly relaxed. We ask that you have the latest version of a web browser on your computer, such as Netscape Navigator or Mosaic. Google Chrome will suffice in an emergency, but that's the #1 requirement, is that you have a web browser on your computer. Any kind of SQL experience is always beneficial. If you've taken any of the database classes at UCSD, you will find that background very helpful for today's information. Although by no means necessary, we seek to explain by showing, and all experience levels are welcome. With that said, let's go ahead and do another poll. This one just post in the chat. Let's take a quick assessment of the people here today. I want to get a good grasp of the vast experience that this particular audience brings to the workshop. For this poll, select A if you're completely new to crushing the databases of your enemies. Select B if you have read about or done minor amounts of SQL injection. And finally, select C if you are so notorious for injecting the SQLs of your enemies that your local government forbids you from connecting to the internet. I'm going to go ahead and open chat so I can take a look at these results. Wow, Eason. That's good to know. Wow, Eason, Tristan, Chris. Geez. This is a dangerous crowd. Well, for those of you that did answer A or B, this workshop is going to be interesting for you. You are going to learn a lot. Even if you have learned stuff about SQL before, the whole title of this workshop is just SQL injection. We do get pretty granular. We talk about all the different kind of techniques that are used. I wish my grades were as good as my poll answers. Drink to that. Okay, let's keep going. So those of you that have seen or attended a workshop of mine called Software Hacking will recall some of the material and challenges I will be presenting here today. There were SQL injection-based challenges baked into that demonstration. Rest assured, though, I did not spend the past 18 hours of my conscious life copying and pasting. There was significant attention to detail with regards to renovating and focusing that curriculum while I was copying and pasting it. We go a lot deeper into the intricacies of database exploitation, and I've even given most of our challenges a facelift to reflect the new ACM portal design. So for example, you're not going to be able to connect to the tried and true acmucsd.co. So if you're going there, you're noticing probably that the domain's been parked. I don't even own it anymore. even though Cloudflare thinks I do. No, it's going to look like this, and it's not at that URL. So you'll notice two things with this challenge. First, you'll notice that it looks exactly like the cutting edge ACM members portal that you may have used to check into this very event. Second, the URL to access this challenge is sadly not acmucsd.co, but rather, and I picked from just the ones I had available, acm.irs.sh. And you might want to put an HTTPS in front of that when you put it into your browser. I let the old domain expire, so this is going to be the one that we're all going to be connecting to right now. I'm going to start, you can feel free to jump into this and just go ham on it if you want. But I'm going to start by giving a demonstration. Perhaps if you're new to this, the first you've ever seen of SQL injection. So let me go ahead and pull up my browser. I hardly even know her. Okay, so if I pull up my browser, you'll see here, and hopefully y'all can see this. Let me know if you can't. I'm going to go to HTTPS. Oop, hold on, I have to do this real fast so it doesn't bother me. Woo! Yeah, nice, quick, small, brisk password. acm.irs.sh. The way this works is very simple. I'm actually going to kind of hold your hand a little bit for this first one. You're going to do exactly as I do. This is a functioning portal. Well, actually, some of these don't work. Forget password doesn't do anything. Sign up doesn't do anything. Sign in does something. You do have to enter credentials, otherwise your login will fail. And there are valid credentials. So I'm going to go ahead and give this to you now. The email that you're going to want to use for this is acm@ucsd.edu. That is the email account that is inside of the system that you can log into. The password, however, is not known to you, the hacker. I do know it. And just to prove that there is a password that works, there you go. Boom. I just typed in the password. You didn't see what it was, but that was the password. So what I'm going to do real fast is something that you won't have to, which is I'm going to change the type of the password field to text so you can see me type in here. It's just a presentation thing. I'm going to go ahead and type something into this that is not the password. The thing I'm going to type into this is a single quote, an or, and then another single quote, a one, a single quote, an equal, a single quote, and a one, and that's it. Now that seems kind of random. Gotta admit, doesn't really make sense where that comes from. Even if you do know a little bit about SQL injection, that might seem random. But as it turns out, that is not the password. And for some reason, when I actually try to sign in with this, it works. So that's literally what I want you all to do. Make sure you can get that working. Get that exact same behavior on your system. Make sure that you can type in that as the password and get into the system. So if I show you the next page here, ta-da, I'm going to go ahead and give y'all a few, 30 seconds maybe to try this out. I want y'all to go to acm.irs.sh, log in with the email acm@ucsd.edu. Try that little magic string that I gave you for the password and just drop a message in chat when you know that you have at least replicated the bypass in your own browsers. I need to make sure that it works for everybody, that there isn't anyone getting left behind. If you can't get it to work, also let me know. But this is your first activity, so to speak. It's like, a minute because you're just basically signing into something. But I've left you the magic string. Go ahead, try it out. Really feel the power course through your veins. And then when that gets old, kind of send a message in the chat to let me know that you did it. And I'll open chat. The case shouldn't matter for the or. It should be able to be any kind of or that you want. Make sure that they're single quotes. That does matter. They're single quotes and not the back tick that's over by the escape key. It's the single quote that's right next to your enter key. I can go ahead and even type it into the chat here. Make sure I'm targeting everybody. Mine says unknown error. So you're definitely missing a character somewhere. It should be or 1 is equal to, there we go. Like if you were to type that in or copy and paste it, that should pretty much work. Yeah, I don't see a problem there. Let me know if that doesn't work out. As long as one person other than me can get it to work, we'll move on. Oh, and as a reminder, the email here is acm@ucsd.edu. And if you're doing this, great. If you're not, take a drink. Damn, Chris, Tristan, Jessica. Wow. Worked. I assume that means it worked. Destroyed. Wow. You are crushing those databases, everybody. That's killer. Good work. I'm in awe. So let's be real here. I'm going to move on from this. Thank you for playing with me, just making sure that everyone can get it to replicate. So you're all probably wondering, at least for those of us that are completely unfamiliar with SQL injection, why does this work, right? If I go into Facebook and try this, it doesn't work. So clearly it's something that we're doing wrong, right? This is like some trick or, you know. And before you ask, no, the password is not equal to this strange looking string that I gave you. The answer is, to everybody's surprise, SQL injection. You just performed an exploit. You bypassed an authentication mechanism. You did that. You scary hacker, you. It's important that you get the taste for it. Anyways, so you're asking yourself, how bad could it possibly be, right? This feels too easy. Isn't this some kind of archaic exploit that's been patched for decades? Is it really all that powerful? And the answer to both of those is yes, which is to say, yes, it has been patched for decades. And yes, it is still the single #1 vulnerability or type of vulnerability on the web today. It's been the OWASP #1 worst vulnerability for like a billion years. Anyways, to kind of justify that, I have some fun examples from the past 10 years. What you just did, SQL injection, has been the exact same type of exploit used in all of the following attacks. There was a breach at the university, the Michigan State University, in which over 400,000 names and email addresses were obtained by like a 17-year-old hacker from the Netherlands who was just like scanning the web looking for SQL injection vulnerabilities, and he found the Michigan State University website and just took everything. The Ubuntu forums breach, which was very famous, which led to the loss of over 2 million usernames, IP addresses, and passwords on the official Ubuntu forums, which is kind of a big deal. Then my personal favorite, the Philippines Commission on Elections breach, in which 77 million records, which represents the entire adult population of the Philippines, were stored in plain text and easily obtained by a hacker via SQL injection, just on the open internet. So yeah, this is something that happened within the past like 5-6 years. You can look all these up. I even have links, so maybe I'll drop them towards the end, but like, this is not something that has gone away, despite the fact that it very well should have. One that I didn't put here is an attack, like the largest, most damaging, like the most financially damaging theft of credit card information ever, like over $300 billion worth of financial loss from one hack that was based around SQL injection. And this was a couple of years ago. Let me look at the chat real fast, just in case there's, yeah. Destroyed. Okay, I got distracted, so take a drink. Okay, so this is a big deal, trust me. Maybe not exactly what we did, but now I'm going to guide you through understanding what we did so that you can understand how SQL injection works and why it's so dangerous. But in order to do that, we have to go back to truly understand how these huge breaches keep occurring. We'll be taking a quick tour of the origin story of SQL. And for that, we have to go back to the greatest time in human history. That's right, the 70s. Truly, just think about it. The early 70s was the birthplace of the greatest and most secure programming language of all time, C. Just think about how many fewer security jobs there would be if we had never decided to use C for everything. The 70s was also when we pretty much figured out the whole hair thing. Pretty much went downhill from there, if you ask me. We also landed on the moon with like over 1 million times less memory than Google Chrome with no tabs open. It was also an era of accomplishment and innovation beyond these things that I have mentioned. And that plays the same for computers. It was an era of computational supremacy. Take a look at this bad boy right here. That's a hard drive, my dude. There's literally no cons to owning one of these things, so we're just going to cover the pros. First of all, this thing is way cooler looking than anything made after the year 2000. It may be large, so yeah, it's way cooler looking. It may be large, but it's also sensitive. One singular dust can spell the end of you and your entire infrastructure. And the third pro, this bad boy can store a whole 50 million bytes. Flash drives nowadays can only store a few hundred gigabytes at most. So this huge storage, though, brings with it kind of a dilemma, right? Basically, especially in the year 1970, how do you even go about using 50 million bytes? The truth is, in the year 1974, there was really only one American company capable of the task. Yeah. Ta-da, it's Big Blue. Back when IBM was known for more than its Watson Super Bowl commercials that are kind of creepy, they knew they had to step up to the task of putting something on this amazing storage, right? And this is the story of the first database ever. It started when IBM contracted researcher Edgar F. Codd to develop a model of storing information at scale, to develop some standard so bloated and complex, nothing would be able to replace it for at least half a century. So unfortunately, though, Edgar was a smart man and invented relational databases, which actually turned out to be a really great idea. IBM pretended to like it and they paid him for it, but when they went to implement it, they gave his plans like a total makeover. They were too sensical and ubiquitous, so IBM had their best engineers develop SQL instead. And that's how SQL databases became the new standard for information storage and retrieval, period. In fact, SQL grew so much that it quickly outgrew its IBM nest and had blossomed into dozens of competing standards just to make the developer experience more exciting, I guess. IBM was actually genuinely thrilled by this, though, because, I mean, it's IBM. They could sell a crap ton of tech support for all the different SQL implementations out there. And they did, and they do a lot still to this day. So anyway, we're going to cut IBM out of the picture now. Let's just talk about the tech. This is how relational databases work. It's essentially a glorified spreadsheet. You start with tables, which are basically just kind of complicated sometimes, but super compact spreadsheets with like rows and columns. It's super useful for highly structured data, like the inventory in a department store. The SQL implementation allowed users to retrieve a ton of information all at once, according to variable configurable stuff. So you could basically change your requests and get different things. For example, you could ask for things like every order from the past 3 days, or return all of Aaron's workshops sorted by YouTube view count. That's the kind of request that you can make through SQL. Anything, it can do it because the data is so structured that it understands it and can display it in any way that you ask for it, basically. Beyond that, though, SQL starts to get crazy complicated when you get into like the relational aspect of it. You have tables that connect to each other in a huge graph, creating complexity. You perform queries across these tables, apply functions to process the results. An example of this would be like, calculate the sales tax on every order of this year, or please calculate my odds in the CSE department lottery. So now I know what you're all thinking. The data being organized and stuff is all great, but how do you actually get data to go into it and come out of it? It's a spreadsheet, right? Well, it's actually very simple. All you got to do is boot up one of your 15 different Electron-based dark mode graphical interfaces that have to do all the thinking for you. Oh, wait, no. So that's actually true. It's how you do things now. But this is the 70s that we're talking about. So your user experience actually looks like this. That's right, terminal only. You have to interact with your database entirely via commands. It has to fit on a line, essentially. In fact, there's an entire structured query language for it. I'm going to drink to that one. And I'm also drinking because I wanted to check chat. Yeah, OG computers are dark mode. Oh, good thing they invented light mode. Hey, this is a cyber presentation that's in light mode. That in and of itself is a pretty substantial thing. Wow. There's some hate being thrown down for light mode allegiance. Remember, everyone, you took a peaceful oath of nonviolence at the beginning of this presentation. I request that you do not crucify those among us who may use light mode. All right, we're going to continue. So structured query language, right? Let's give some examples, right? I think that's the best way to dive into the syntax. That will help you understand how it works a lot better. Let's say we want to perform a query to, for example, fetch all usernames. It actually just looks like this. Select username from users. This literally returns a list of all the users, all the usernames in our users table, right? Username refers to the field that we want to retrieve. From users refers to we want to retrieve them from the users table. Let's say we want to fetch the emails of every admin user in the system. Well, that request looks like this. It's select email this time. We want the email, not the username, from users, but we only want the admin emails. So where access equals admin is how you basically make your query more specific. You saying, I only want the elements of my table that meet this condition, where access is equal to admin. We can also add new rows to the spreadsheet with an insert command, which in this example lets us add a new email to the users table, right? Insert into users, I'm going to give them an email. Here are the values, and then I give them the value of the email that I want to insert. And that literally, like if you imagine the spreadsheet analogy, this literally inserts a new row into your spreadsheet. So all the way at the bottom, boom, it just added the new row. The only thing that's in it is an email. There's all the columns are empty except the column that is for emails. And then that column says Aaron@fbi.gov. So actually, that's not too bad. Like, honestly, reading this, I feel like it's kind of intuitive what each of these do. I'm almost over-explaining it. It almost seems easy, right? Well, things are about to get a whole lot more complicated because enter the 90s, right? Websites are suddenly a thing. Turns out we suddenly have to store structured data for users across the world in some distributed way. It also turns out there was this thing called relational databases, and SQL invented way back in the 70s, right? So maybe they're related. What could possibly go wrong with this idea? And honestly, by now, I think we have enough prerequisite information. Let's talk about how we hacked ACM. We are ready to go over the actual code of the website you just exploited. We want to understand why what we did allowed us to bypass the login. Here's what we imagine the backend code that processes our login requests looks like. Basically, at the top of the file, we're getting the email that is coming in through the request and the password that is coming in through the request. Next, based on, those are our user inputs, email and password. Next, we need to build the query itself, the query we're going to send to the SQL server. So we say, select star from users. Star is just a way of saying get everything, get the username, get the password, get email, get it all. But that's not all we want to do. We also want to make sure that we add on to the query, make sure you only select the users where the email is equal to the email that's indicated, right? And the password is equal to the password that was given. That way you have kind of like the double, you have to meet both conditions. That's what that and means. You have to have the right email and the matching password in order for the result of this query to return. And that's literally what we do. We just run this query via some database driver, db.run, we pass in the string, and what comes out is assumedly a row of information. It's a single user, preferably. We need to see if there were any users that met the condition of having that email and having that password. So literally we'll just check, was the result non-null? In other words, it was defined. We don't really care what the information was, really. We just care that there was a user that met that condition. If the result was non-null, then we go ahead and log in. Otherwise, the result was null. In other words, there was no user that had that email and that password, so we're just going to fail. We're going to report to the user, bad login failed. So this is pretty much exactly what's in the code base on the back end. I actually have it in a GitHub repository that I'll post later. But this is pretty much exactly what it looks like. I kind of shortened things in a few places to make it more readable for the slides, but this is the whole thing. It's not that complicated. So what could go wrong with this? Here's your problem, actually. We're allowing user input to control the logic of the query, right? This query that we're building here on lines 24 and 25, there isn't really a distinction just because of the design of SQL, like the language itself. There isn't really a distinction between the logical instructions of a SQL query and the actual data we're trying to query by. Therefore, a user, which includes someone who's trying to log into the website, with context can feed crafted input to take over the query behavior, which is really complicated sounding. It's just honestly my attempt to sound smart. The bottom line is, let's actually look and see what happens with the input that we used, right? This was our input. We gave it acm@ucsd.edu, and we gave it this weird password thing that was not the right password. Let's just see what this means. There's the magic string. Let's see what this does to the final query. So we're building our query out. We assign in our email and password, and we populate it with the values provided, but we notice that there are control characters provided with the password item. What I mean by control characters are like single quotes, right? That's supposed to delineate when a string starts and ends. So if we were to highlight that last line there, and password, if we were to change the highlighting to reflect what SQL actually recognizes that line as being, we actually, don't miss it, look at that line. It would look like this. In other words, the password string ends immediately. It's an empty string. Or is now a control, just like and then what's to the right of the or is 1 is equal to 1. So if we're just, all you math majors out there, is 1 equal to 1? Hopefully you'll say yes. And is the password equal to the empty password? Probably not. We know that the password is at least not empty. So in other words, the thing to the left of the or evaluates to false, and the thing to the right of the or evaluates to true. So it basically simplifies when SQL goes to process it down to this. But here's the thing. False or true is just true. And if we have a selection clause where email is equal to this and true, it doesn't really matter what happens after that. Look at this. There's no password check anywhere in this code anymore. It's all just reduced down. And if we reduce it down further, this is essentially what gets processed by the login. It's only checking to see what your email was. It's no longer even checking what the password was. So in summary, the core of the issue here is that SQL does not distinguish between the query data and the query logic. That is something that made sense when all of SQL had to just be on the terminal, right? Back in the 70s, that was who would worry about SQL injection back then? You're just sitting there at your desk trying to do work. But when it made the leap to the web, it didn't quite realize that this stuff coming in from the web was not necessarily safe and trusted. I'm going to go ahead and open chat because it's pretty active right now. Yep. Oh God. Okay. Let's see. Good thing I came late, so I didn't have to take the oath. All you need is the valid email. Yeah, it's big brain. It is true. ACM, UCSD, true. Wow, there's way more people in here than there was earlier. This is exciting. Please take a drink. Let's drink to that. We finally understand it. So why is the or evaluated before the and? Even if it wasn't, the outcome is the same. Wouldn't you agree? If we did like and false, it would evaluate to false, but then it's or true, so it just evaluates to true. So in this particular case, order of operations doesn't matter. I showed it like it evaluated the right before it evaluated the left, but that's just because it made it more clear what it was doing. So yeah, there are cases where it does matter, and you can use like parentheses to delineate it. Okay. Looks like we're ready to keep going. Just continue pinging the chat if you have any questions. Thank you for sticking with me here. We're a pretty good chunk into this presentation, so I appreciate your patience. But how are we on time? Well, we're pretty good. We're pretty good. We're, just to clarify, we're over halfway through the presentation, so don't feel like this is going to take up your whole evening. Thank you for sticking around. So yeah, hey, where'd the password query go? That part wasn't really necessary. In summary, the core of the issue here isn't that bad. Like, you might be tempted into thinking it could be worse, right? If you were to pull up like the tier list of bad shit that could happen to you online, right? Someone can log in with you is like A tier. That's pretty bad. You don't want someone to be able to access your Facebook and all the weird things you like. But if someone knows your password, that is inarguably worse. Not only is it kind of like this weird personal violation, it's like someone's getting inside your head almost. They know your password. It's also something that they can use on other websites, because let's face it, we all reuse passwords. So if they know your password, they stand a decent chance of getting into your accounts elsewhere. And you know, even if you are one of the rare people for whom that is not the case, it is true for a vast majority of people. Knowing your password is much more valuable than just being able to log in as you. So yeah, but at least it's not that bad, right? At least there's no way to like get your password out of it, right? So from bad to worse, I'm now going to explain that, as it turns out, in like 99% of cases, SQL injection exploits always allow the attacker to exfiltrate any kind of data they want, really. And that'll become more apparent throughout the night as we kind of go on. For example, we might have SQL code that looks like this, right? And we might use the result in a response like this. We access the username explicitly and don't return the password anywhere, right? So there's no way that the user can steal it. If this is the code that's on the back end, there's no way that I can inject this to steal the password, right? Well, it's important to remember that we completely control the query. We can overwrite huge portions of it, and probably most of it if we do like, you know, specially crafted stuff, like chaining joins together and such. So because SQL is very complicated, it has a lot of overhead. In general, if any SQL result is sent back as a response, right, and the attacker can see it, we can hijack the result and make it whatever we want out of the database. What's even more surprising is that you can even return information when the server response is not visible at all. This is known as blind attacks, and we'll talk more about them later. They're very interesting and very bleak. But yeah, so if any SQL result is sent back as a response, we can hijack it. Super, super, super simple example. Let's say I have a SQL injection and I change that query, that select name from users. I change it to this. I change it to select password as name from users. Well, I didn't change the backend code. All I did was change the query, right? And it seemed from looking at line 26, response send result.name, that surely it would have been safe to send back the name. But because SQL is so powerful, I can do crazy things like fetch the password instead, name it name, instead of having it be under like result.password, just store the password under result.name. And now it doesn't matter what your backend implementation is. I'm finding a way to get that information out there. It doesn't matter what part of the query you're sending back to the user as a response. I can find a way to get the information from the database that I want in through that hole, no matter how small that gap is. SQL is very powerful that way, which again, wonderful feature to have when you're working at the terminal in the 70s. Now that it's being used for this back-end application that needs to have a super like narrow span of side effects, it's a disaster for security. So here's some good news. In actuality, this isn't that bad. Businesses know that their databases get stolen all the time. And in general, it is well known to not store plain text passwords, which means even if you were to do an attack like this, you wouldn't get the password. You would get this, just a kind of garbage string. The passwords are just generally hashed, right? So in actuality, when I said that this was the backend code for the login request, what it actually looks like is this. The only difference is the password is piped through this hashing function. Maybe it's MD5. Hopefully it's not MD5, but let's say in this case it's MD5. And because what's stored in the database is also MD5, if you take the same password and hash it, you'll get the same hash out. So we're only comparing the hashes down here in the SQL statement, but that works just as well. But it does mean that the database doesn't actually explicitly store your password. Now, theoretically, it's no longer possible for any kind of SQL exploit to result in the attacker to be able to steal their users' passwords because they're all hashed, right? And hashing is one way. If you have the MD5 hash of something, you can't go back. So MD5 comparisons will still work. And this has an added benefit. Your password is now technically completely safe from any kind of injection whatsoever. Does anyone in the chat know why you can no longer inject through the password field? Anyone care to guess? Also take a drink. Yeah, your injection is hashed. That is correct. The hashing will succeed no matter what. It doesn't matter what bytes you put in there, what the string looks like. But Bryce is correct in that he says it will MD5 our SQL code. In other words, MD5 always is letters and numbers, and that's it. There's no way that an MD5 hash will ever contain control characters, which is the single quotes, the hyphens, the equals. It will only ever contain letters and numbers. So in a way, it kind of sanitizes that field. There's no way to control things through the password field anymore. And actually, that leads us directly, and thank you, by the way, everyone, for responding, into our next exercise, which is funsies. Level 2 this time, we're going to hack ACM again. The way that you're going to do it is that there is a new version of the website that you hacked at the beginning of the workshop that now has the function that was implemented here. It now has the MD5 hashing, right? So the password field can no longer be injectable. We already talked about that. We said it. We know that it's true. You feel free to try it yourself. But that doesn't mean we're completely safe. And that's the purpose of this exercise. The URL you're going to go to this time is acm.irs.sh/level2. Your goal, and really your goal, I'm not going to do this one for you, is to use SQL injection to bypass the login again. But you're going to have to do things differently this time, because now we are sanitizing the password. It's being hashed. So theoretically, it's not possible to inject through that field anymore. So I guess the question is, can you find a way to inject through the email field instead? You have about 5 minutes for this, starting now. I'm going to go ahead and send a link in the chat to this for those of you that don't want to type it. And I'm also here to answer questions for these 5 minutes. So What did you use to make the presentation? People don't believe me when I say PowerPoint. I used PowerPoint. I don't know what you want from me. Like, I'll send you the PowerPoint afterwards. So I can't take credit for the design, only the implementation. The design of this PowerPoint comes from, I just sent the ACM irs.sh link. The design of the PowerPoint comes from Emily Nguyen, and then I think one of the Dimensions design people that she was working with. She was the one that decided to make new templates for ACM. She never finished them, so I finished one of them, and so that I could use it because I liked it. So yeah. The only downside is, again, it is light mode. This is a cybersecurity organization, so most of the cyber people that are here are having their eyes burned out right now. Hopefully this workshop doesn't go too late, otherwise it will start disrupting people's sleep. So yeah, I'm going to give you all a few minutes. Yeah, weirdos like Eason. It is worth noting that Emily Nguyen, the person that made this design, does use Discord light mode. So interpret that as you will. More light mode. The light mode article. Step into the light. I'll go ahead and pause recording for a minute. Let's just hope I remember to restart it afterwards. Okay, welcome back. I didn't forget to hit re-record again. Y'all did wonderful. So yeah, if you bypass the login, say so in the chat. If not, I'm going to go ahead and just show you what that looks like real fast. It's not too long. If I go to, what is it called? It's called level 2, isn't it? Level 2. You'll notice that I did keep my word. If you put ACM at UCSD here, and then you follow up by trying to type the exploit from before, which you can't see right now, but trust me, I tried to do it. It fails. So it truly is not injectable through that field anymore. However, arguably, we don't need a password, because if we escape the quotes surrounding the email and then comment out the rest of the line, it's like there's no clause requiring the password at all. And if I just hit sign in, it says, yeah, you're good to go. So that is one way to do it. It's one of the easiest possible ways. In fact, this works all the way back on level 1. You could have just done this all the way at the beginning, and it would pop you in. And arguably, that's a lot easier than the magic string I gave you from before. But yeah, don't think too hard about that one. Might make you sad. Let's just move on with the workshop here. Yes, we all forget about the recording. Okay, so let's actually walk through it, because that was a little fast. We imagine that, the email and the password are here, and the password is like some long hash by the time it gets put into the SQL query. You'll notice here that if you fix one leak by patching up the password field, you will inevitably have another one somewhere else. Any user input can be used to completely take over your SQL. You see here that if we addendum the email to be the malicious version that has the single quote and the 2 hyphens after it, essentially how SQL will interpret this line now is everything in red there is now a comment, and it just disappears. And now you're left with the same query that we had the first time, which is no password required. Yet again, all we check is the email. We can literally give it any email in the system, and it will log us in as that person. So that's poor design. But this kind of brings up an interesting point, which is, how do you actually go about preventing SQL injection, right? It kind of seems like any foothold whatsoever is enough to completely compromise your system. And the answer, canonically, is a feature called prepared statements. Prepared statements looks a little bit like this. And this is implemented in every single major SQL library that's out there. If you go to actually write database code nowadays, you're going to see code telling you to not do it this way. The way that we have it right now is it just slaps it directly into the string. Instead, the library will have functions that can safely sanitize user input for you, and you should not try to do it. You should use their functions to sanitize the input. And usually it's implemented in a very easy way. For example, with SQLite, it's as easy, just changing the code here, not the query itself, but it's as easy as taking the email and password out of the query and only including the question marks. Now you'll notice in the actual query itself, there's no user input at all. That might as well just all be one static string. And then when we go to actually run the query, we pass in the user input as additional parameters. So we pass in the query that has question marks in it. Then what the database driver will do is it will process email and password and stick them into the query, but only after putting it through this like very battle-tested input sanitization. And note that this finally provides the separation of data and logic that was causing us problems before. User input is quarantined and filtered, separate from the command itself. You, the programmer, don't have to worry about how it works because let's be honest, we'd all get it wrong probably. But it does work. Prepared statements are the canonical solution to SQL injection and should be employed for basically all scenarios constantly. Like this is not that hard of a change to make. And the most, you basically gain everything from this. This blocks almost all SQL injections, period. So, I mean, that seems pretty easy. Workshop over, right? Okay, so it's a lot more complicated than that. First of all, even if prepared statements have been around forever, there are so many websites and so much infrastructure out there that just does not use that, whether it's just out of date or has never been brought up to that standard. It is a huge mess. It is a problem that will continue to bite us for probably another 20 years. But now we're going to pivot away from the funsies and we're going to talk about some tools, because this is the part of the workshop that was not in my software hacking workshop. We are going to talk about, well, first we're going to talk about some general techniques that are used for SQL injection, the main types of injection, but then we're going to talk about tools. Like if you are actually trying to break into a system via SQL injection, what are the tools out there that you can use to automate your exploitation and then, like attack with it. So we're going to go over that because these tools can do way more than you or I can. SQL injection is a very deep rabbit hole, and these tools will gladly dive down that rabbit hole for you so you don't have to worry about it. But I do want to talk about some of the high-level concepts. The first high-level concept I want to talk about is stacked versus unstacked. When I say stacked versus unstacked, I mean your SQL injection vulnerability is either a stacked vulnerability or an unstacked vulnerability. And it's a super important distinction to make. It's literally the difference between an attacker being able to steal some information out of your database and an attacker being able to just absolutely destroy you and everything you love and completely take over all of your infrastructure. So it is really a question of just how owned are you? So the pivotal question when it comes to stacking injections is, what if I insert a semicolon into the statement, right? That's a control character. The semicolon is a line terminator, and it indicates the end of one SQL statement and the beginning of another. Can I just add whatever new SQL commands I please? And in some cases, yeah, you can. You can just write your own commands. Let's see an example of this. If I set my password field to this gigantic payload, let's play it out and see what happens, see how SQL treats it. So we do build our query just like before. We set password equal to this giant query. If we update the syntax highlighting to show how SQL evaluates this, we actually get this. All of this is now control characters, right? And if we put these two commands on separate lines, so it's easier to read, we get this. So now the original select statement isn't going to successfully log us in anymore, but who cares? In the second statement that we added by using command stacking, we were able to add our own user. Now we can just log in with our own credentials that we created for ourselves. No more injection necessary. we can literally log in without using any kind of exploit from now on. If your injection vulnerability supports command stacking, there is almost no limit to the amount of mischief that you can cause with it. You can change the admin's passwords. You could delete every account in the database. You can nuke it all, just never to be recovered again. You can even take complete control over the physical server hosting the website in many cases. In fact, I even have an example of that. There is a particular input that's famous in SQLite. Here's an example of a payload that can be used to take control of a PHP server. It creates a new database entirely on the host file system and uses SQL commands to kind of populate it with PHP shellcode. Now, if this PHP file can be navigated to in the production web server, we can pass arbitrary commands through to the host operating system, yada, yada, yada. The point is, while this is just one example, if your SQL injection vulnerability is stackable, you can take complete control of your victim's hardware more often than not. And at that point, it doesn't really matter what you're doing to their database. You can just take over everything that they own, really, to own it, so to speak. But this is, again, just one example. It's a little contrived. To be completely honest with you, knowing what to do when you find a stackable injection is important, but it's not that common, right? As you can tell, being a stackable exploit is like a very serious thing. It basically means your server is completely unprotected. In cases where a web server's backend is injectable, it's very rarely stackable. So it's important to look at what happens when you're unstackable as well, just to know what you're limited to, right? And a good way to think about this is to, and if you've taken the database courses class, this is going to be super helpful for you. You're going to know what I'm talking about immediately. The truth is, there's more or less 3 types of SQL commands, right? There's the data definition language, which allows you to specify the structure of your data and its relationships. There's the data query language that we are familiar with that basically just consists of the select command, but the select command is by itself very complicated. And finally, there's the data manipulation language, which consists of commands that add and remove entries to that big spreadsheet that we've defined. Understanding this little collection of things here is important because when you're trying to exploit an unstackable injection vulnerability, that is to say, you can't add your own commands, you are limited to manipulating the command that was already being used there. Practically speaking, that means if you're exploiting a data definition command, you can perform almost any functionality in that category. You can create, drop, rename, truncate, whatever. But you're not going to be able to query the database with it, at least not usually. Likewise, if you're exploiting a data query language command, like we were with select earlier, you're not going to be able to use data manipulation functionality no matter what you try to inject. These are the limitations that we will be working with most of the time when working with unstackable vulnerabilities, and by extension, most SQL vulnerabilities. So we generally are confined to one of these 3 categories when we choose to exploit a given vector. So that's one distinction, right? There's another distinction that's arguably more important, which is blind versus non-blind exploitation. You'll notice from the subtext here that the difference has less to do with the capabilities of the hacker and more to do with how long it takes, right? Although it may seem pretty black and white at first. When you're looking at a non-blind SQL injection, all that means is you're attacking an environment where the SQL server's output is sent directly back to you, the user, right? You can usually, in that circumstance where it's non-blind, where you get output, dump the entire database pretty easily. This has to do with the nature of the functionality that is being implemented on the SQL server. For example, a search functionality on a website returns the server's output to the user and is therefore considered a non-blind function. If you can exploit that, what you're going to get is server output. So that is a non-blind exploit. If you can get it to return more than it's supposed to, you'll just see it, right? But there's other functionalities that still perform queries but are completely blind. For example, a login page is considered blind, since the user will not be told what the data that came back from the query was, just whether or not it was successfully found. It's literally a Boolean, found it or didn't, right? So this distinction is a little bit subtle, but I think the examples are kind of clear. I'm going to give a few more examples, but if you have any questions about this while I'm going, drop a chat. Like I'm watching the chat right now, but no one said anything yet. So go ahead and take a drink too. I've been talking for a hot minute. But yeah, if at any point something was unclear about this distinction, I'll provide more examples, but speak up as sooner rather than later. So the main takeaway from this is that blind versus non-blind, they have different exploitation techniques. Let's take a look at them. So when looking at non-blind SQL injection, there are basically two techniques. There's union-based SQL injection, which relies on like short-circuiting the where clause of the select command to return more than the typical amount of elements. That's what's being used in this picture here, the DVWA. That stands for Damn Vulnerable Web Application, by the way. It's like a great little tool for beginners to try out a lot of these techniques that I'm sharing with you. And I'll be sharing more information on that towards the end. But the second major technique that is non-blind based is error-based SQL injection, which relies on the errors returned from the SQL Server itself to get more information about what the schema is. So for example, I can try inserting different shapes of rows into a table with the hopes that the error message that it will give me back will tell me more about how it's actually structured. So I know about the actual fields that are defined on that table. So I would say non-blind is honestly relatively straightforward when you want to get information out of a non-blind injection vulnerability, whereas it's not immediately obvious how you would extract the same information from a blind injection. That said, in general, what's really surprising is even though non-blind makes it so easy and blind seems so obtuse, you can pretty much get anything you want out of a blind vulnerability. Anything you can get out of a non-blind vulnerability, you can generally get out of a blind one, which was very surprising to me when I learned about that. But this is where the automated tools come in. So to show this, let's look at a few techniques. Here we have, once again, the example of the ACM IRS login page, right? Most login pages by their nature are blind because they will not tell you anything other than if the login was successful. However, there's a technique built around that Boolean return value of yes, it worked or no, it didn't, called a Boolean-based blind attack. If we do have a blind SQL injection vulnerability at our disposal, we can basically like add conditions to the where clause, kind of like what we were doing earlier, that will cause the overall response to either succeed or fail. And we can do this over and over and over again incrementally to determine what values are in the database. So the database is never reporting back to us, but by process of elimination, we determine what must be in it. For example, this example will help. Imagine a where clause that reads, select the user such that their email is this, acm@ucsd.edu, and the first letter of their password is A. And let's say that returns false. So we know that their password does not start with A. We ask again, does it start with B? Does it start with C? And so on until, hey, the login succeeds when I ask if the password starts with D. So now we ask for the next letter. We say, give us the user such that the password starts with DA, DB, DC, and so on. And using this much slower technique, we can eventually get pretty much any database field we want out of the database. Even though it never tells us explicitly what it is, we know by process of elimination that we're doing here, the iterative process of determining the values, we know what it is. Now, what happens when you have a SQL injection, but you don't even get the true false out of it, right? And sometimes maybe there's an endpoint that just returns when it's done, and you don't know whether or not it succeeded or failed. Well, it turns out we can still do everything that we could do with the Boolean-based blind, and we can still extract any value that we want from the database. But now we need to send queries that take different amounts of time depending on the values that are in the database. For example, we can have a query that returns in 50 milliseconds if the first letter of the password is A, and in 5 milliseconds if the second letter is something else, or if the first letter is something else. So basically the same strategy. We will know based on the amount of time that the response takes what the first letter ended up being. It's still just a Boolean test. We just don't get the explicit yes or no. We're basing it off of the time that it computationally takes to give us the answer. These two blinds are generally the most complicated, but they both follow the same general principle. It's essentially the same strategy. It's just understandably, it might take even longer than the Boolean-based blind, since we have to add measurable delay to every single request in order to actually do this. If all of this sounds really painful to you, then don't worry, it really is. But there are insanely sophisticated automated tools out there that you can kind of just point at blind vulnerabilities, and they will just enumerate the crap out of it and make it pretty easy. In fact, I actually want to show you how to use one of them on acm.irs.sh here in a second. So actually, on that topic, I had a quick poll for everybody in the chats. Thank you, by the way. We have great participation here today, and I appreciate that. We're going to do a knowledge check based on the things I just talked about, which was we talked about the types of SQL vulnerabilities. And now I would like you to apply it to acm.irs.sh. acm.irs.sh belongs to which of the following categories, A, B, C, or D? Because this is like an actual, like, it's not an opinion, it's a fact. When you post it in chat, try not to look at what other people post. I'm sorry. Next time we'll have legitimate polls working, but for now, just use the chat. Try to not be emotionally swayed by other people's responses when you respond to this. So is the portal that we've been messing around with, is it stackable or is it unstackable? And is it blind or is it non-blind? That is the question I want y'all to answer. So A, B, C, or D. I'll go ahead and give y'all 30 seconds. I think there's one response so far. Also take a drink, that's your punishment. All right, try to get them in the next like 10 seconds or so, since we're nearing the end of our time here. Even if you're not sure, just send the one that you're most comfortable with, just so Crystal doesn't feel too alone in chat there. Send your answers, send your answers. And 3, 2, 1. Okay, polling's closed. Thank you everybody for participating. The correct answer here was B, unstackable and blind. The way that, well, hopefully everyone who responded was in agreement that yes, it is a blind vulnerability because it's a login page, right? There's only a you succeeded or you didn't. You don't actually get to see what the output of the SQL server was. It's also unstackable. There's a few reasons why it's unstackable, but it basically like, so the number one reason it's unstackable is because I would not publish a stackable server on the open internet, because random bots would like take it over in milliseconds. They would just be scanning the internet looking for stupid people like me, and they would just instantly like use some automated tool to take over my server and use it to send out spam or something. So I did not send out a stackable server, but actually by default, the version of SQLite that I'm using in the demo that you've been using, acm.irs.sh, actually doesn't even like support it really. Like, it's really hard to get a stackable vulnerability. Like, it's not something that could happen unintentionally, really. That's part of the reason why it's pretty uncommon. It's a lot more uncommon to be limited to one query at a time. Well, thank you everybody for your participation. I have one last little thing for you. That's right, it is finally time. Everyone who stuck it out through my ramblings, I greatly appreciate all of you. I have one last demonstration for all of you before you head out. This is truly a demonstration. This is the so-called final funsies. It's basically an exercise where I'm going to show you about a sophisticated tool called SQL Map, and I'm going to use it on acm.irs.sh. You can feel free to also use this. I cannot stop you. You can do it at the same time as me if you want. In general, because we're short on time, this is more of a demonstration. I'm not going to go over how to install it or use the tool beyond what is absolutely necessary to show you that it works, right? This exercise will be something that y'all can do watching the workshop recording. That said, I suggest if you do come back and attempt what I'm about to attempt, pull the acm.irs.sh website off of GitHub to run it locally on your machine. That's actually what I'm going to do right now. I'm not even going to do it on like the production server. The first reason is I don't want anyone to like disrupt the web app for anybody else, since a blind attack can be kind of taxing on it. Secondly, I want y'all to be able to read the server logs of what SQL Map is actually sending to the backend, which I can only do if I'm running it locally. So again, I'm just going to go ahead and do it real fast, and everyone could just check out what I'm doing. So I didn't practice this. So let's try this out. First thing I have to do is get acm.irs.sh running locally on my computer, which I believe I have it set up here. I can just do that, and that should work pretty much instantly. We're going to test it by going away from the production version and going to localhost, which is the, there we go. Same thing, same version. In fact, if I, if I type in acm ucs, I'll type in the exploit, it'll work. And the benefit of this is I can actually see that output. I see what the query sent to the backend is. So this is going to be really nice for when we take a look at what SQL Map is sending. So SQL Map is an open source SQL injection tool. It's available on Kali Linux. Installing it on Windows is kind of a pain. So I actually have it here in like a WSL image. I probably have a command to do what I'm looking to do just in my history, but I'm going to go ahead and type it from scratch. So let me go ahead and hide the meeting controls. So to use SQL Map, I'm just going to do SQL Map. I'm going to indicate the server I want to execute it on, which is localhost, and the exact the exact URL is like /login. That's the actual like endpoint that it's sending the requests to. Then I need to specify the data that I want to basically inject. So I want to inject the email field. So I'm just going to do like email is equal to acm.ucsd.edu. And then what I want is to be able to type any SQL commands I want. SQL Map literally has support for the ability to input your own SQL commands, and it will use whatever blind attack it needs to use in order to exploit that. So I believe that's just going to be SQL shell. And if I do that, I'll go ahead and hit no on that. Yep, there you go. Perfect. So I actually ran SQL Map earlier. So it already found, this part takes a long time. It already found a time-based blind attack here on this email field. And so if I go in here and I now have effectively popped a SQLite shell, we know that this is a blind input, right? There's no way I can do something like steal what the plain text password is out of the database, right? Well, with a tool like SQL Map, I actually totally can. I can do select password from, let me type it right, from users, and hit enter. And then let's pop open this. We can see it's sending some weird requests in the back end over here. It says, did I type it wrong or something? Oh, no, I have to like hit OK. Let's see what I did here. Password from user. Oh, I think it's just user. I typoed the name of the table. Whoops. So yeah, there it goes. And I have to, it'll ask me for like some optimization stuff. So yeah, it's chugging away. You could see these commands are ridiculously complex. This is never, ever, ever something you want to do by hand, but you could see what I was talking about here. Like, is it less than or greater than or equal to this character? And you can actually see, look, it's starting to type out what the password is. It's not fast. It takes a long time. We're only printing one element from the database, but by using a timing attack, we're pulling the password out of memory from the database, despite having no access to it whatsoever. It's very cool stuff. And it's still chugging over here. So yeah, it says, boom, I've got your password. It's ACM rocks. Go try it. It should work on the full website. That should be like the official password. If I do ACM UCSD and I just do ACM rocks, it says, yep, that is the password. So I was able to pull that out of the database despite not having direct access to it, despite it being behind a blind thing. Automated tools are awesome. Yeah, that was kind of what I wanted to show you. Actually, that was the nicest presentation I've ever done. That went off basically without a hitch. Let me open chat. I think I missed some things. Yeah, it is cool. It is cool. Okay. So yeah, actually, that's all I have for you tonight, folks. Thank you so much for taking your time out of your busy Tuesday evenings to come listen to me ramble. I hope you all learned a lot. I'll stick around for a few minutes to answer any lingering questions, but then I'm going to call it quits because I need the sweet embrace of unconsciousness. So yeah, that's it from me, folks. Thank you, everybody who came and watched.